This is the recording of Topic 15-5, Applications of Quadratic Functions, Day 1. Our central question today is, how can I apply my knowledge of quadratic functions to real-world situations? If you need to check your assignment 15-4, you need to pause the video at this time and check your answers. Otherwise, the video will continue on. Today we're going to talk about applications of quadratic functions. Our first example is we have a rancher has 100 meters of fencing with which to build a rectangular corral. The graph below shows the relationship between the area and the length of the corral. So before we start working with the graph, let's notice some things about it. Look at your x-axis. And looking at your x-axis, notice that it represents the length in meters. So it's the length of the fence in meters. Then look at your y-axis. Our y-axis is the vertical axis. It represents the area in square meters. And so the title of our graph is the area of the corral. Now we're going to be able to answer questions based upon the graph itself. The first thing we want to do is identify the independent variable. Remember that the independent variable is your x, also known as your input, and also known as your domain. We have used all these different words to represent the independent variable. And in this case, because we are talking about a scenario here, our independent variable actually is the length of the fence itself, and the units are meters. Our dependent variable, other names that we have used for dependent variable is your y, or your output, or even your range. So those are common vocabulary words, but for this particular case, our dependent variable is along our y-axis, which is the area, and that is in units meters squared, or square meters. What to identify the x-intercepts? So as we identify the x-intercepts, we're going to look on the x-axis and find where does my graph cross the x-axis. I'm going to draw my 2 points, and I'll see my x-intercepts. The first one is at 0, 0, and the second one is at 50, 0. So this means that I have an area of 0. In both of these cases, my y value is 0, so this is where is the area 0. And the area of my corral is equal to 0 when the length of my fence is either 0 or it's at 50 meters. So next question is, does the graph have a maximum or minimum? We look at our parabola, notice that it is opening down, and so it has a maximum. E says, what is the vertex of the graph? So again, I'm going to look at my graph. The vertex is this maximum point. And when I name it, I'm going to use the x-coordinate first, followed by the y-coordinate. So the x-coordinate will come on down to the x-axis, and we'll see that x-coordinate is 25. And the y-coordinate, go over to the y-axis, and notice the scale on this one. I have 4 spaces. 1, 2, 3, 4 spaces in between the 600 and 700. So each space represents 25, so this would be 625. That is the vertex of the graph itself. So we have just found that our vertex is at 25 and 625. Now, our next question says, how does the x value and the y value of the vertex relate to this scenario? Remember that our x value represents the length and the y value represents the area. This was a max point, so this tells me that with a length, which does not have an E, so with a length of 25 meters of fence, we have a maximum area of 625 meters squared, or 625 square meters. So we are relating our x value, which was the 25, to the y value, which is 625 of that vertex, and it's related. It tells us that with a length of 25 meters of fence, I will have a maximum area, it should be area, of 625 square meters. G says, find the possible dimensions of the corral if the area is 525 meters. So what's given is the area, or our y value, is 525. That should be meters squared, y'all. So 525, I'll go to my y-axis, and I'm looking where it's 525. And remember, since there's 4 of them, I know 525 is at that first one, so I'm going to do just a line straight across. This is 525. Now I'm going to find on my parabola where 525 intersects that parabola. From there, then I can come on down and see, hey, this can give me a length of 15 meters. So if the area of 525, I know I can have a length of 15 meters, or notice I could also have a length of 35 meters. Now the question was, what are the dimensions? So if I know that my length is 15 meters, I need to figure out what's my width. Well, we know the area of a rectangle is length times width. We were given the area is 525, and we know that one of the lengths is 15. I need to figure out what the width is. So we can solve for the width by dividing both sides by 15, and we'll get that the width is actually 35 meters. So that means I will have the dimensions of a 15 meter by 35 meter corral. Now it just so happens that, hey, my width was 35 meters. So I don't have to figure out what happens if my length is 35 meters. I know my width is going to be 15 meters. In this case, it happened to give us both of them. So the dimensions again is a 15 meter by 35 meter corral. Our second example, we have 3 rockets are launched at the same time. Each person in the group chooses one rocket and answer the following questions for rocket number 3. So again, let's first notice, what does our graph tell us? Notice we have an x-axis, and it's time in seconds, represents time. Also notice how the scale is on this x-axis. And so to get to 1, we're actually going 4 spaces to get to 1. And then another 4 spaces to get to 2, another 4 spaces to 3, another 4 spaces to 4. Our y-axis is our height, that's in meters, and this scale is counting by 5s. Our graph here is for rocket number 3. Our first question, from what height was the rocket launched? So really this is asking, where does the rocket begin? I use that because in all our previous conversations and our previous topics, when we talk about the beginning, we're talking about the y-intercept. The same is going to be true for this scenario. So if I look at my graph and look on the y-axis, the y-intercept is where it crosses the y-axis, and here's my y-intercept. The y-intercept is at 0, 10. This means at 0 seconds, for its initial launch, then it is at a height of 10. So I'm going to answer the question. And this is 10 meters. B says, when did the rocket hit the ground? Well, if my y-axis tells me how far up and how far from the ground it is, I'm going to look, when does it hit the ground? The ground is actually when it's my x-intercept. That's just another way of asking about the x-intercept. Except because we're talking about rockets, I'm not going to say what's the x-intercept. I would say when does the rocket hit the ground? So you can see that this rocket is going to hit the ground sometime between 3.75 seconds and 4 seconds. I could probably guesstimate it would be something like 3.8, but this is a good answer. It's somewhere between 3.75 seconds and 4 seconds. So when you have a question like this on your test, and if it's multiple choice, your answer or possible answers is going to fall somewhere in between 3.75 seconds and 4 seconds. C says, when did it hit its greatest height? So again, let's look at our parabola that's being drawn from it. And I can see this has a maximum point right about here. Well, it's going to hit its maximum height. This is asking when, so that's asking about a time. I'm going to come on down to my x-axis, and we'll see that this is somewhere between 1.75 seconds and 2 seconds. So between 1.75 seconds and 2 seconds, it reaches its greatest height. D, what is its greatest height? Well, if I want to find the height, we're looking at the y value here. So let's go over to our y-axis. And I see that the greatest height is somewhere between 65 and 70 meters is the greatest height. Again, because of the scale and we're estimating, I'm giving you some distances in between that it could be. That way, again, if it's a multiple choice and I give you 4 possible answers, the only answer is the one that falls between 65 and 70 meters. How many seconds was your rocket in the air? So it started off at liftoff at the 10, and that's at 0. Time is 0. And then it's going to go up, reach its maximum, and come on back down and hit the ground again. And so it is in the air then a total of somewhere between 3.75 and 4 seconds. I don't know exactly, but I do know it is between 3.75 and 4 seconds. So again, if this was a multiple choice, that answer would have to, the correct answer would have to be between those two numbers. F says, for approximately how many seconds was the rocket 45 meters or higher? So let's look, 45 meters or higher, this is talking about a y value, 45 meters or greater. So I'm going to go to my y and see where it's 45 meters, cross on over, find where it intersects. So anything above this is going to be higher than 45 meters. And I can see that the time that is going to be, this comes on down, that is 0.75. That's a 7. And then 3 is my other number. So to find how many seconds, I need to know how many seconds pass between them. We'll do 3 minus 0.75, and that'll give us 2.25 seconds. Now, a couple of things before we finish is I didn't talk about what was our independent and our dependent variable. So let's look at this. We look at our graph just like we did previously. The independent is our x, and so our independent variable is time. Dependent variable is our y, and our dependent variable is height. And then we know that the height depends on the time. We know that because we have often said our dependent depends on the independent. So how high our rocket is going to depend on how much time has elapsed since it was initially launched. Okay, so the last thing for us to do is or last thing for you to do is to write your summary. And before we write the summary, let's go back to what our central question was. It was, how can I apply my knowledge of quadratic functions to real-world situations? So notice when we did these real-world situations, we were still using x-intercepts and y-intercepts. We were still using our vertex, but now it actually means something. It's relating whatever our x represents to our y. We can also still determine independent and dependent and determine what depends on what. So I'm going to leave it to you to complete your summary, and this concludes topic 15-5.